Welcome back to AnTick Machine, the channel where we explore the timeless beauty of machinery, craftsmanship, and the history behind industrial progress. Since the dawn of civilization, wood has been more than a material. It has been a partner in our growth. From humble shelters to grand cathedrals, from sailing ships to aircraft frames, wood shaped the very path of humanity. Among all wooden innovations, plywood stands as a quiet revolution. Strong, flexible, and efficient, it changed how we build our homes, our furniture, and even our vehicles. Yet, few ever witness the fascinating journey of how simple logs transform into these perfect, layered sheets. Today, we step inside a plywood factory, where tradition meets modern engineering, to uncover how raw timber becomes one of the most important building materials in the modern world. The trimmed logs are now loaded onto a conveyor system, lined up for the peeling process. Hydraulic arms lift and place them onto a rotating line. In older times, this was a manual job, requiring great strength and coordination. Today, machines do it with perfect accuracy, ensuring every log is ready for rounding. Before peeling, each log must be perfectly round. Specialized lathes rotate the log against sharp blades, shaving away irregular bark and uneven surfaces. The goal is a smooth, uniform cylinder, the ideal shape for veneer peeling. The scent of freshly cut wood fills the air, and the rhythmic hum of the lathe sets the tone for what's to come. This is the heart of plywood making. The rounded logs are fed into a giant rotary lathe, where the log spins rapidly against a stationary knife. As it turns, a continuous ribbon of thin wood veneer unrolls, much like peeling an apple. This process reveals the natural grain of the wood in perfect sheets. Each layer, delicate yet strong, becomes the foundation of the plywood core. With the core complete, attention turns to the outer layers, the face veneers. These are the most visible parts of the plywood, chosen for appearance and smoothness. Workers inspect each sheet by tapping and examining grain patterns, rejecting any with knots or imperfections. Only the finest veneers are selected to give the plywood its beautiful, natural finish. Behind the scenes, the heartbeat of the factory is the boiler room. Here, powerful boilers generate the steam needed for drying and pressing. This steam energy system is often fueled by waste wood, an efficient recycling of byproducts. Nothing goes to waste. The heat and pressure from this section keep the entire production line alive. Next, adhesive preparation. The core layers are coated with synthetic resin using automatic glue spreaders. This ensures even coverage. Too much glue weakens the board. Too little fails to bond it properly. The machinery spreads the resin like a thin, consistent film, a crucial step before final assembly. Now, the complete plywood stack with core and face veneers moves into a high-pressure press. Again, intense heat and force merge them permanently. The result: a flawless, multi-layered panel with exceptional strength-to-weight ratio. It's this structure that gives plywood its remarkable stability, resisting warping, shrinking, and cracking over time. The large pressed boards are then trimmed to standard dimensions. Precision saws cut along the edges, removing excess material. This step ensures every sheet meets strict size standards for commercial use. Each panel emerges clean-edged and square, ready for finishing. To prepare the surface for coating, sanding machines smooth out any imperfections. Massive rotating drums fitted with fine grit sandpaper glide over the panels, refining their texture. The once rough surface becomes silky and ready for finishing. This process reveals the beauty of the wood grain and the craftsmanship behind the machinery. Attention now shifts to the edges, where consistency is just as important. Edge sanders polish the sides of each panel, removing burrs and sharpness. Every detail matters. Even a single uneven line can affect how panels join during construction. To further strengthen the sheet, glue is applied along the edges. This seals the plywood from moisture and adds extra rigidity. As the glue dries, it forms an invisible armor, protecting the core layers from humidity and time. Tiny voids and gaps on the surface are filled with wood putty. This ensures the plywood appears flawless, smooth, and uniform. Skilled technicians inspect each sheet by hand, ensuring quality meets both mechanical and aesthetic standards. The finished panels now go through a dipping process. They're submerged in a chemical solution that protects the wood from insects, mold, and decay. This treatment extends the lifespan of plywood, especially for outdoor or industrial applications. Every finished sheet is then stamped with factory information, quality grade, and specification. This simple mark represents countless hours of labor, precision, and engineering excellence. From the hum of rotary lathes to the heat of hydraulic presses, each moment in this process reflects decades of craftsmanship and innovation. Plywood may seem ordinary, yet behind every panel lies a remarkable blend of nature and engineering. In our next episode, we'll step into a modern mill, where advanced automation and high technology transform timber on a scale never seen before. Stay tuned as AnTick Machine explores the evolution of woodworking from past to present. From the hum of rotary lathes to the heat of hydraulic presses, each moment in this process reflects decades of craftsmanship and innovation. Plywood may seem ordinary, yet behind every panel lies a remarkable blend of nature and engineering. In our next episode, we'll step into a modern mill, where advanced automation and high technology transform timber on a scale never seen before. Stay tuned as AnTick Machine explores the evolution of woodworking from past to present. Today, we step into West Fraser, one of the world's leading lumber producers, where advanced technology and automation now drive the same principles that once relied purely on craftsmanship. Here, computers analyze what the human eye once judged by instinct. Giant machines perform the work of dozens of men, yet still rely on the same fundamental respect for wood, a living material that must be understood, not just processed. The contrast is striking. Where the old mills hummed with manual labor, this modern facility breathes with the rhythm of robotics, scanners, and precision engineering. Every step, from log delivery to finished lumber, is designed for efficiency, sustainability, and safety. Yet, amid the hum of conveyors and lasers, the soul of the craft remains the same purpose that has guided woodworkers for generations: to turn raw timber into something lasting, something useful, something human. Join us as we explore the extraordinary journey of wood inside a West Fraser mill, where tradition and technology intertwine to shape the timber of tomorrow. Every story begins in the forest. Massive trucks roll in from distant harvesting sites, each carrying a heavy load of freshly cut logs. At the mill's entrance, the air carries the scent of pine resin and damp bark. Here, the logs are weighed and scanned. Sophisticated computer systems record each load, species, length, diameter, and even internal density. This digital fingerprint helps determine how each log will be processed for maximum yield. Before cutting, every log must be stripped of its bark, a tough outer layer that can damage blades and interfere with drying. The logs move through a rotating drum fitted with steel teeth that tear away the bark in seconds. In older times, this was a manual, back-breaking task. Now, automation does it with remarkable speed and precision. The removed bark isn't wasted. It's recycled as biomass fuel, helping power the mill's boilers. Once cleaned, the logs enter the sawmill's core, the head rig. This enormous bandsaw is the first to meet raw wood. Guided by sensors and lasers, it determines the optimal cutting pattern for each log, balancing between efficiency and grain quality. In a single fluid motion, the blade slices through the heartwood, producing thick cants, the rectangular blocks that will later be refined into boards. In just moments, what once took a team of men now happens automatically, with accuracy down to a fraction of a millimeter. As each cant exits the head rig, it's scanned again using 3D laser mapping. This data-driven step identifies imperfections, knots, cracks, irregularities, and decides the best cuts to produce lumber of the highest value. Optimization software, guided by algorithms, plans every slice before the blade ever touches the wood. It's a blend of computer logic and natural artistry, finding order within nature's irregular form. Before peeling, the logs must be softened. They are submerged into massive vats filled with hot water, maintained at precise temperatures. This soaking process, lasting several hours, relaxes the wood fibers and makes peeling smoother and cleaner. The hot water also equalizes internal moisture, preventing cracks or splits. In older days, this was done in open pits or by pouring hot water manually. Now, advanced sensors monitor every vat to maintain the perfect balance of heat and once softened, the logs move to the roundup machine, a lathe designed to remove bark and irregular edges. The logs rotate against sharp cutters that shave them into smooth, perfectly round cylinders. The goal is absolute uniformity. Even a small imbalance can affect the veneer's thickness later. Each finished log, now called a peeling bolt, gleams with moisture, ready to be transformed into continuous ribbons of veneer. Now, the heart of the operation, the spindleless lathe. Unlike traditional lathes that grip the log with steel spindles at both ends, this machine uses rollers and sensors to rotate the wood while peeling thin sheets off its surface. The blade remains fixed while the bolt spins, creating a continuous ribbon of veneer, sometimes hundreds of feet long. Thickness can range from 0.6 to 3 millimeters, depending on the final product. It's mesmerizing to watch. A solid cylinder of wood unrolling like a scroll of history, revealing the hidden grain within. The long sheets of veneer are immediately fed into a clipper. Guided by sensors, this machine trims the continuous ribbon into standardized sheets. Each cut is swift and precise, ensuring edges are clean and corners square. Defective sections, where the grain is uneven or cracked, are automatically detected and clipped out. In this way, quality control begins right from the moment the veneer is born. Not all veneer sheets are perfect. Operators stand by the line, pulling out those with defects or irregular grain manually. Their trained eyes catch what even advanced sensors sometimes miss: small knots, mineral streaks, or micro tears. These imperfect sheets are repurposed for inner layers or recycled into chips. It's a balance of technology and human intuition, working together for the best result. Nothing in the mill goes to waste. Rejected veneers, bark, and edge trimmings are sent to the chipper. Massive spinning blades reduce them to small wood chips, a key raw material for pulp, particle board, or energy generation. Every rotation of the chipper symbolizes modern efficiency, turning byproducts into resources. As the peeled logs become too small for veneer production, the remaining cores, called peeler blocks, are cut into pointed ends by a machine known as the pointer domer. This shaping allows the cores to be fed easily into other sawmills or repurposed for smaller timber applications. Nothing leaves the factory without a purpose. Even these wooden remnants continue their journey elsewhere. All bark, chips, and sawdust are collected and sent to the hog, the energy plant of the facility. Here, the materials are burned in massive boilers to generate steam and electricity. The steam powers dryers, presses, and heating systems throughout the plant. This self-sustaining loop dramatically reduces fossil fuel use, embodying the modern principle of energy from waste. The same trees that feed production also fuel it, a perfect circle of efficiency. Fresh veneer contains too much water for gluing. In this stage, large continuous dryers use hot air to remove excess moisture. Sheets travel through the tunnel-like chambers for several minutes, emerging lighter, drier, and ready for bonding. Proper drying is critical. Too wet, and the glue won't bond. Too dry, and the sheet becomes brittle. Infrared sensors continuously monitor temperature and humidity to ensure perfect results. Once dried, veneers pass through scanners that measure density and moisture content. This data helps assign each sheet to the right layer of the plywood stack: denser sheets for the core, lighter and smoother ones for the face. Sorting guarantees that each finished panel meets strength, flexibility, and visual standards. This level of precision was unimaginable just a few decades ago. Now it's standard practice in modern mills. Now comes the transformation from sheets to plywood. Layers of veneer are coated with resin adhesive and arranged in alternating grain directions, a technique that gives plywood its unique strength and stability. These stacks are then loaded into a massive hot press. Under extreme heat and pressure, the resin cures, and the layers fuse into a single, solid sheet. Temperatures can exceed 130 degrees Celsius, and pressure surpasses 1,000 psi. Within minutes, dozens of thin veneers become one unified panel, strong, durable, and ready to serve. Beyond standard plywood panels, some veneers are laminated into beams and headers, engineered components used for construction. These pieces require thicker veneer and stronger adhesives. After pressing, they're cut, trimmed, and tested for strength. It's the ultimate demonstration of wood's potential, a natural material reborn through precision engineering. Each beam is a testament to how far the plywood industry has evolved, combining the warmth of nature with the power of technology. From the quiet vats to the thunder of the press, each moment in this process is a symphony of precision and purpose. Plywood has come a long way, from hand-peeled logs to high-speed lathes and fully automated lines. Yet, behind the machinery, the same principle remains: to honor the wood and to craft something enduring from it. Join us again on AnTick Machine as we continue exploring the machines, materials, and minds that shape the modern world. One layer, one invention, one revolution at a time. From the slow, hands-on craftsmanship of traditional plywood making to the high-speed precision of modern West Fraser facilities, this journey reflects how far humanity's ingenuity has come. In the old days, every sheet of wood carried the marks of human labor, measured, careful, and personal. Today, machines perform the same tasks, with accuracy, safety, and consistency beyond imagination. Yet both share the same spirit: transforming simple logs into something of lasting value. Whether guided by human hands or automated systems, the heart of woodworking remains: a harmony between nature, skill, and innovation.